Alright, hello. Today I'll be doing energy and rates. It's Chem. Well, I'm gonna start with the first question. And the question says industrial processes, in order to be economic, require that products are formed as rapidly as possible at a reasonable cost. The production of ammonia through the Haber process involves an exothermic reaction between nitrogen gas and hydrogen gas to produce ammonia gas. A. Oh, A. Write a balanced equation for the reaction, including all the heat of reaction. Including the heat of reaction. Okay. So it's basically said this in the question. It says nitrogen and hydrogen. So N2 plus H2, and they're both gases, and this will become NH3 ammonia, and it'll be gas as well. And see if it's balanced. Okay, there's a 1 nitrogen, there's 2. Okay, so this has to be 2. And 2 times 3 is 6. 2 times 3 is 6. And then plus heat, because we have to write heat, and the net heat will be less than 0 because it's losing heat to the environment from the reactants to the product. And for part B, it asked, explain how increasing the temperature will increase the rate of this reaction. So basically, when you increase the temperature, when temperature is increased, the average, oh my god, average kinetic energy of the particles are increased um this allows a greater proportion of particles to have greater or equal energy as the activation energy, which increase, oh my god, the frequent, it's asking increase the rate of reaction frequency of successful for collisions um increase increasing the rate of reaction. And for part C, this question says explain how increasing the pressure of the system will increase the rate of reaction. Increasing the pressure, the pressure is basically like you decreasing is similar to decreasing volume. Is done by increasing the pressure is done by decreasing volume, making particles closer to each other, increasing the frequency of successful collisions, increase the rate of reaction. And then for part D, says explain how the use of catalyst will increase the rate of reaction. So the use of a catalyst will create an alternative reaction pathway with lower activation energy, allowing greater proportions of particles to successfully react, increasing rate of reaction. And for part E, it says to draw an energy profile diagram for the reaction. So basically, this is just entropy. No, not entropy, enthalpy. Enthalpy, which is H, and this will be the reaction progress. And then basically it starts from here, and then it does that, and then it continues off like that. And this will increase and go down. This is activation energy. This is change in heat, and then this will become the products, which is the 2NH3 gas, and this is the N2 gas plus 3H 2 gas. And that's basically it for this reaction and this end of this question. We have a second question. The second question asks, a student was experimenting with ways of increasing reaction between marble chips, which is calcium carbonate, and hydrochloric acid. And part A says to write a balanced ionic equation for the reaction between calcium carbonate and hydrochloric acid. Okay, honestly, you can just write the actual equation, but I want to write the full equation first. So basically it's just calcium chloride, calcium carbonate plus hydrochloric acid, and it becomes because it's like an acid base, it goes like calcium chloride, which is a 2, plus, and okay, and also there's hydrogen carbon dioxide as well. Oh my god. CO2 2 plus H2O, and let's see if it's balanced. The 3 O's are balanced, the C's balanced, the H2 is not, CO is not. So 2 here, and that's it. The ionic equation. Just have the not only the ionic particle. Okay, good kind of particles. Okay, yeah, but like, okay. And we don't need to include chloride anymore, so it's just CaCO3 plus 2H plus becomes calcium 2 plus CO2 plus H2O. And for part B, it asks, give 3 ways a student could increase the rate of reaction, explain how each change causes an increase. So you can increase temperature, increase surface area, or use a catalyst. And the catalyst and temperature, we have talked about it before, so it's basically just the same explanation. And the increased surface area is, well, when surface area increase, more of the more of the particles of the reactants collide and react, increasing the frequency of collisions, increasing rate of reaction. Okay, now for part C, it asks us, what impact would using acetic acid rather than hydrochloric acid have on the rate of the reaction? Okay, so basically we have to know that because a hydrochloric acid is a strong acid while acetic acid is a weak acid, acetic acid have a lower concentration of H plus, and this leading to slower rate of reaction. That's basically it for this part of the question. That's it for the 2 questions. Oh well, hopefully you learned something. Bye bye.